Hi guys, so today I want us to talk about trigonometric ratios because this is a very important topic, and you pay close attention as we move because it is really an important topic. So the first thing that we are going to do when you're dealing with trigonometric ratios, there is something that we call SOHCAHTOA. SOHCAHTOA. Now, this is a very important principle that guides how we operate on the trigonometric ratio, like SOHCAHTOA. So simply means the sine ratio is this is the sine ratio. Ka means this is the cosine ratio, and then toa means this is the tangent ratio. What do I mean by that? Another thing that you have to understand is that this principle only operates with right angled triangles. All right? That is what it deals with. It only deals with right angled triangles. And we can use this ratio to find out the dimensions of a triangle as well as the angles that constitute this triangle. All right? Like for example, we can have a triangle with different sides and different angles. We can use the SOHCAHTOA principle to determine all its sides and all its angles. That relationship is what this principle supports. Now, another thing that you have to understand is that one thing that I've said that is very important is that this principle deals with right angled triangles, which is very important. Another thing that you have to understand is that there is something that is challenging students, and you also need to understand it very well. And that is how to label a triangle. How to do what? How to label a triangle. Like for example, we have a triangle like this one. All right? This is a right angled triangle. Now, you must always understand that the side, this side, that is always opposite the right angled, the right angle is what we call the hypotenuse. Hypotenuse. All right? Now, we have two other sides, and that is the adjacent and the opposite side and the adjacent side. Now, these ones are determined by the position of the angle in the triangle. Like for example, if we have angle 1 here, this is the opposite side of this angle, while this one here is the adjacent side. Again, we can have the same triangle. We can have the same triangle like this, Of course, here is right angled, and then we have the hypotenuse here, because we said hypotenuse is the side that is directly opposite the right angle. And then we have another angle here. Let's say it's angle 2. This one was angle 1, now this is angle 2. We have this triangle here, and then now this side now becomes the opposite. All right, but because this is the hypotenuse, now this one is the adjacent. All right, so that is how you must understand how to know these dimensions. The hypotenuse is constant because it is always the side that is directly opposite the right angle, but the opposite and adjacent sides, they always alternate in relation to the angle you are dealing with. All right, the angle you are considering will determine the position of the opposite side and the adjacent side. That said and done, how do we apply these ratios? Okay, now how do we apply these ratios? First of all, I said the SOHCAHTOA principle is only applied in right angled triangles. Again, I went ahead and said that how do you find these dimensions in this triangle? All right, I said the longest side, or the side that is directly opposite this right angle, is the hypotenuse. This is the right angle. The one that is opposite is always the hypotenuse. And then I also said that the opposite side and the adjacent side, they are not constant. They change in relationship to the angle that you are considering. Okay, so that said and done, now how does this SOHCAHTOA operate? All right, for example, sin theta, okay, sin theta, from the word so, we are dealing with opposite and hypotenuse. So sin theta here is going to be opposite over hypotenuse. Okay, and then we also have the cosine. So cos theta is going to be, from here we have the adjacent and the hypotenuse. So we have the adjacent and hypotenuse. Okay, that is how to find cos theta. And then we also have tan theta, which is going to be opposite, because from here we have tan theta, which is opposite and adjacent. So you come here and say tan theta is opposite over adjacent. All right, so this principle up here can be connected to this principle down here. This is another way of representing that principle. So knowing this SOHCAHTOA, this is the one so opposite hypotenuse, ka adjacent over hypotenuse, tan toa opposite over adjacent. Now I want us to deal with examples. Okay, example 1. We have a triangle like that, and then this is the right angle, and then we have here this angle to be 43 degrees, and then we have here to be 12. Okay, I said there are two things that you have to consider before you start. Is it a right angle triangle? Yes, it is. Okay, and then another thing is, what is which sides have you been given? You've been given an angle and a side here. And then you are told to find the value of x, this height. Okay? So in other words, you have the angle and you have the, from this, you know very well that this is what? This is the opposite side. And of course, this is the what? The hypotenuse. So opposite and hypotenuse, if you come to the opposite and hypotenuse, then we are looking for sin theta. All right? The opposite and hypotenuse, I'm sorry for that interruption. The opposite and the hypotenuse, it means if you have the opposite and you have identified the opposite and the hypotenuse, then you have the angle here, then it means from this relationship we are looking for sine theta. So you are going to say sine theta is equivalent to the opposite over hypotenuse, which is going to be what? It is going to be, the opposite is x, the hypotenuse is 12, and this is going to be sin 43. Okay? So x, if you put this over 1 and then you cross multiply, x times 1 is x. So x is equivalent to 12 sin 43. All right? And what is the answer? You take your calculator, you take 12, you multiply by sin 43, and then you get 8.18. This one was in centimeters, this one is also in centimeters, and that is your answer. All right? We are going to example 2. And under example 2, we also have another triangle like that, and it is a right angle triangle, of course, and then we have here to be there to be how do I know this dimension? We have here to be 27, and then we have here to be y, and then we have here to be 5. So you're being told to find the value of y. You know very well that under this, you know this one is this is the opposite. Okay, no, this is the hypotenuse. Hypotenuse is always the one which is directly opposite the right angle, and then we have this one in relation to this angle. This is going to be the adjacent. Okay, adjacent. So when we have an angle 27, an adjacent side of 5 centimeter, and a known side which is the hypotenuse, how can we find the hypotenuse? Okay, so we have adjacent and hypotenuse. If you come up here, when you have an adjacent and a hypotenuse, then you are going to find the cosine of that meaning. So cos theta is equivalent to adjacent over hypotenuse. Okay, so what is the value of so this one is cos 27 is equivalent to adjacent, which is 5, over hypotenuse. If you cross multiply, we are going to be h cos 27 is equivalent to 5. So h is 5 divided by cos 27, which is going to be 5.61 centimeters. All right, so you just have to identify you have to identify the dimensions. Is it the adjacent? Is it the opposite? Is it the hypotenuse? A hypotenuse is the side that is directly opposite the right angle, and then the opposite is the side that is directly opposite the angle that you have been given, and then the adjacent is now the one that is here. Okay. Another example. I want to make another example here so that we proceed. I have another right angle triangle here. Okay, and here is 3, here is 5. Then we have a known angle, all right, here, and then you're told to find this angle. All right, from the relationship that we have, if this is the angle, then the one that is opposite is the what? The one that is the directly opposite is the opposite side, and the one that is directly opposite the right angle is the hypotenuse. Okay, so now we have an angle, we have the hypotenuse and the opposite side. So where we have hypotenuse and the opposite. Okay, so where, if you come here, where do we have hypotenuse and the opposite? That is sine. So you are going to say sine theta is equivalent to the opposite over hypotenuse. Okay, so sine theta is equivalent to the opposite. What is the opposite? With this angle here, angle theta, the opposite is 3 and the hypotenuse is 5. Okay, so what do you do? What do you do? You're going to do this. You're going to realize that theta alone is going to be the sin or the sine inverse of 3 over 5. Okay, the sine inverse of 3 over 5, and that is going to be 37 degrees. All right, because if you want to leave, if the sine is here, when it crosses the other side is going to be the sine inverse. Okay, so that is what you do here. That is 37 degrees Celsius, and then we also have another one. So I have talked about how to deal with the cosine, the tan, and everything. So you must always know that under trigonometric ratios, you must understand that this deals with right angle triangles. That is 1. 2, you have to understand that you must identify the right angle, and then the side that is directly opposite the right angle, that is the hypotenuse, and then the adjacent and the opposite sides now vary depending on the position of the angle that you're putting under consideration. All right, so that is how trigonometric ratios function. And I said trigonometric ratios can be used to identify sides of a right angled triangle, sides that have not been given, if you are given an angle and another side. And then I've also said that it can also be used to identify the size of an angle when we have sides of this right angled triangle given. All right, so this is a very important topic, very simple but very complicated, and that is the concept, that is how it's done. So I wish you well. Thank you for being here, and kindly subscribe to my channel I'm working on other areas that I'm going to present soon. So a lot is coming and a lot is going to be here. Thank you very much. Have a lovely time. Bye.